Welcome to Lecture 3.4, Solving Rational Equations and Radical Equations in Math 1314 College Algebra. Today's picture is from earlier in my career. I had worked in corporate America in a technology company, first as a programmer and systems engineer, and then later as a training specialist for international employees, and then doing strategic planning and communications. I showed this picture because about 10 years into my career, I just felt like I wanted to stop making money. Not really, but I wanted to make a difference. And so my company put me on loan to South Dallas. And it was one of the greatest experiences for me. It was a very transformational thing because I really thought I had my act together and I was the great white hope and was going to help save people. And really what I learned is that I don't really know how to save anyone else. And that all you really have to share is your story, and then people can pick up pieces that they are interested in that are relevant to them and not. And this is actually incredibly freeing if you see yourself as this great hope or someone who's got to fix things, then it puts a lot of responsibility on you, especially when it comes to other people. And it's really my opinion now that each of us has to take care of ourselves while interacting and supporting each other. And that's what our thought for today is. A mentor is someone who allows you to see the hope inside yourself. A mentor is someone who allows you to know that no matter how dark the night, in the morning, joy will come. A mentor is someone who allows you to see the higher part of yourself when sometimes it becomes hidden to your own view. This is a quote by Oprah Winfrey. And in that last picture, there were actually 3 or 4 different mentors of mine. Didn't need a mentor, and at least not in my mind when I first went there. Like I said, I thought I was the great white hope. But what I learned, and from my mentors there was people that had lived in the community I was working in, had much more experience and insight into the troubles and how to move out of them than I could. And so my mentors were not people that were that only had more experience and better experience or more education. In this case, there were some that had more education. Lala is sitting to the right of me, and she had her master's degree at that time in social work. But also people that had less education than me, but had more life experience relevant to this. And I kind of used to think of mentor as something that I would do, that I would mentor others, especially as an adult. Why would I need a mentor? And I've really changed that now. I recognize that we all need support and encouragement and an outside voice to give us reflection. Mentoring is a brain to pick, an ear to listen, and a push in the right direction. What I do now, I have several mentors. I'd say for the last 10, 20 years, I've always had mentors, and I've asked people to be my mentor. Usually what I do is I find someone that I admire. I like the way they work or the way they do things, and also that I have a personal connection with. We get along well. We can joke, we can have a drink, etc. And I have, as of yet, had anyone to refuse being a mentor. I've had multiple people ask me, like, what do you mean? What do you want me to do? And for me, it's just, I want you to be a resource if I have a question and just to give me your honest feedback. And it's been a very honoring thing for them. I think they felt very, again, honored by my request. And it's been very helpful to me that there are times when I can't see completely clearly. Maybe I'm emotional, maybe I don't have the experience, and to have an outside voice has been very helpful and calming and helped me make good choices. Each person holds so much power within themselves that needs to be let out. Sometimes they just need a little nudge, a little direction, a little support, a little coaching and the greatest things can happen. So I guess my question to you as you hear this, who are you a mentor for? And who are your mentors? And if you don't have any, I highly suggest that you get some, because this can really help the trajectory of your life, especially when you have decisions to make. It doesn't have to be problems, it could just be big decisions. Okay, so today we're going to look at solving rational equations and solving radical equations. Rational equations. Equations containing rational expressions are called rational equations. These look like fractions. You can even see in the word rational, there's the word ratio, which is a comparison of one thing to another, which is what a fraction is. So the example is 2x plus 4 divided by x plus 2 plus 3x over x plus 2 equals 7. Solving such equation requires multiplying both sides by the least common denominator or any common denominator to clear the equation of fractions. So let's look at an example. Here we have x minus 8 over 3 plus x minus 3 over 2 equals 0. Well, the common denominator, if I just multiply these common denominators, I get a denominator of 6. If I multiply both sides by 6, now I don't like the way they've done this. I really suggest that you multiply each term. 6 times x minus 8 over 3 plus 6 times x minus 3 over 2 equals 0 times 6. Sometimes here students will cancel out the 6 with the 3, but the 6 is multiplying both. It's distribution. So there's a 6 on top of the first fraction. There's a 6 on top of the second fraction. And so I prefer to do it more like this. Multiply the 6 times each term, and then I can cancel out. This then gives me 2. 6 over 3 is 2 times x minus 8, plus 6 over 2 is 3 times x minus 3. We can do the algebra here. I'm not going to walk through these steps. But we end up with x equals 5. Okay? Let's look at another problem. X squared divided by x minus 3 equals 9 over x minus 3. Here we have the same denominator, so we're just going to multiply both sides by the denominator x minus 3. Again, we've put it here, we only have one term on each side, so we can see it. But the x minus 3 is going to cancel out in each case, and we just get left with x squared equals 9. And so x would equal plus or minus 3. Now, these are possible solutions. It's very important that you check answers in rational expressions. So if we check x minus 3, we plug in negative 3 to both sides and see what happens. If we plug in negative 3, we end up with negative 9/6 equals 9/6, and that is true. So negative 3 is a solution to the set. If we plug in 3, we get 9 over 0 equals 9 over 0, which might look true to you, but what's the one rule? We cannot divide by 0, so this is not defined. So this is not a solution to this problem. So there's only one solution, and that is negative 3. It is very, very important, as you can see here, when you're doing the math, you may come out with what are called false positives or false solutions. When you're manipulating the original equation, you may get new solutions which are not possible solutions to the original equation. So it's very, very important that you check. Let's look at one more of these rationals. So here we have two different denominators, x plus 3 and x minus 3, and they're not numbers, so it's a little more confusing. So if you remember when we had 2 and 3 as separate denominators, we just multiplied them. And so that's what we're going to do here. We're just going to say the least common denominator is x minus 3 times x plus 3. We are not going to multiply this out by FOILing. We're just going to leave it in this form. We're going to multiply both sides by this, which means multiply each term. So we have a term here, 6 over x plus 3, another term here, 3 over x minus 3, and on the right side we have a term as well. So we're going to multiply the LCD, x minus 3 times x plus 3 times each term. So you can see it there, times the first term plus the product with the second term equals the product on the third term. Well, in the first term, we get the x plus 3's cancel out. In the second, the x minus 3's cancel out. And we get simply 6 times the quantity of x minus 3 plus 3 times the quantity of x plus 3 equals x squared minus 9. This is FOILed out, but it's a sum and a difference, and the sum and a difference is equal to the difference of the squares. So now I'm just doing algebra, 6x minus 18 plus 3x plus 9. Simplifying, combining like terms, I get 9x minus 9 equals x squared. And this actually gives me, if I subtract 9x from both sides and add 9 to both sides, I end up with 0 equals x squared minus 9x. Now why did I do that? Because we have a square, and we know that for quadratic equations we set them equal to 0 to solve. If I then factor an x out of x squared minus 9x, I get x times x minus 9. If I set each of these factors equal to 0, x equals 0 or x minus 9 equals 0, I get two possible solutions. Again, it's very important that we check these. In the first case, I've plugged in 0, and we see that it's true. In the second case, I've plugged in 9, and again, we see that it's true. So in this case, both 0 and 9 are solutions to the original equation. A radical equation is an equation in which variables appear in one or more radicands. Okay, these are roots, square roots, fourth roots, etc. The radical, this is a radical sign, the little house. The expression inside is called the radicand. Okay, so the first example, the square root of 2x minus 5 minus the square root of x minus 3 equals 1. The second example, the fourth root of x plus 3 is equal to 2. We're going to use something to solve these kind of problems called the principle of powers. And for any positive integer n, we're talking about the exponent, if a equals b is true, then a to the power of n equals b to the power of n is true. Now, how are we going to use this? Well, if you raise a root or a radical of an nth root to that same power, the radical disappears. So in the second example, if we raise the fourth root of x plus 3 to the fourth power, we can do that in this equation if we also do it to the other side. And what happens here is when I have a fourth root to the fourth power, the radical just disappears and I'm left with x plus 3. Okay, so let's look at some examples. To solve a radical equation, we will isolate the radical on one side of the equation, then we will apply the principle of powers that we just spoke about. When a radical equation has two radical terms on one side, we isolate one of them and then use the principle of powers. If, after doing that, we still have a radical term, we have to repeat that process again, isolating another radical. And we're going to look at an example as well, but first let's do some simpler examples. So here we have solve the square root of 3x plus 1 equals 4. Okay? So what we're going to do here is use the principle of powers. And so we want to get rid of the radical. We want to get rid of the square root. And so we square both sides. Again, a square root squared just becomes the radicand, or what's inside. So they kind of sort of cancel out. And 4 squared is 16. Now it's simple algebra, subtract 1, divide by 3, and we get x equals 5. Just as it was with rational expressions, it's also important to check with radical equations. So we plug in 5, we get the square root of 3 times 5 plus 1, which is the square root of 15 plus 1, the square root of 16, which is 4. And we do see that 4 equals 4, so we're in good shape. This is a solution. Let's look at another one. 5 plus the square root of x plus 7 equals x. Solve this problem. Okay, this one's a little more complicated. The first thing we're going to do is to isolate the radical on one side. And to do that, I'm going to subtract 5 from both sides, right? I've got a 5 up here. I want the radical by itself, so I'm just going to subtract 5 from both sides. Now I'm going to use the principle of powers. I'm going to square both sides. Now on the right side, I have a FOIL problem. X minus 5 squared is x minus 5 times x minus 5. It is not x squared minus 25. Okay? When we multiply that out by FOILing, on the left side, the radical disappears and we're just left with x plus 7. On the right side, x minus 5 squared is equal to x squared minus 10x plus 25 if we FOILed that out. We see that we have a quadratic equation. So what we want to do is set the equation equal to 0, and we'll do that by subtracting x from both sides and subtracting 7 from both sides. When I do that, I get x squared minus 11x plus 18. I can factor this now to solve, or you could use the quadratic formula. If we factor it, we get x minus 9 times x minus 2. Setting each of those factors equal to 0, we get x equals 9 or x equals 2. Again, remember, it's very, very important that we check every answer with radicals and rationals. So we plug in 9. 5 plus the square root of 9 plus 7 gives us 5 plus the square root of 16, 5 plus 4. It indeed does give us the answer 9, so this is true. When we plug in 2, we get 5 plus the square root of 2 plus 7. The square root of 2 plus 7 is the square root of 9. The square root of 9 is 3. We get 5 plus 3. 8 does not equal 2, so we have a false positive here. I really want you to pay attention to that. Make sure that you check your answers, because you'll get it wrong if you don't check your answers and you include a false positive answer. So the only solution to this problem is 9, because 2 does not work out. Okay, this is probably the most complicated problem when we're talking about radical equations, and this is when there's more than one radical. And it's not really that complicated. It gets a little bit with FOILing, etc., and especially FOILing with a radical, okay? But what we're going to do is we're going to isolate one of the radicals, use the power principle, and then if there are any radicals, we're going to isolate again, okay? So first I isolate one radical. I isolated the square root of x minus 3 by subtracting the square root of x plus 5 from both sides. Now we're going to square both sides to get rid of the square root of x minus 3. This is a FOIL, okay? It's not 16 minus x plus 5, okay? It doesn't cancel out that. We have to do a FOIL here. This is 4 minus the square root of x plus 5 times 4 minus the square root of x plus 5. I'm not going to go through that FOIL, but here it is. So on the left side, the radical disappears and we simply have x minus 3. When we square out this term, we get 16 minus 8 square roots of x plus 5 plus x plus 5, okay? Now again, remember, when we have a radical equation, we want to isolate the radical on the side by itself, all right? So I'm first going to simplify the right side. I've combined the 5 and the 16 to get 21. Now I'm going to move everything over. Whoops. If I subtract x from both sides, these disappear. Minus 3 minus 21 gives me minus 24. Equals negative 8 times the square root of x plus 5. So here between these two steps, I've subtracted 21 from both sides and I've subtracted x from both sides. Now I want the radical there alone. It's better to go ahead and get rid of any constant multipliers, so I'm going to divide both sides by negative 8, and I end up with 3 equals the square root of x plus 5. Now I can I can use the principle of powers to square both sides. So I can get rid of the radical and now solve. It's important for me to check. This is a different way of checking. So what you're seeing here is the table, and what they've done is put in two equations under the y equals button on your calculator. It's just a different way to check. Y1 equals the original equation, Y2 equals 4. And so we go down and we look at that. That was the answer. We go down and look at when x equals 4, do they both also equal 4? 4 was the solution, and 4 was also the problem. All right, good luck on this chapter and section. This is really one of the more challenging ones. Do plenty of problems and reach out if you need any help.